Why? So the question is, why would I be interested in the rate of change between these 2 points? Because basically, I'm really, so let me give an example what this means. So I always tell this example to my students. So let's suppose I decide to drive to New York. I start at 7 o'clock in the morning. I get there, I don't know, 3 o'clock in the afternoon. And you call me in the evening and you ask me, what was your average velocity, speed, average rate of change of distance with respect to time? In other words, what was your speed, or your average speed on those 200 miles? And I will say, okay, no worries. I will exclude the time that I stopped for lunch, bathroom, whatever. And I'll say, okay, I drove 200 miles in 6 hours. And I'll tell you 200 divided by 6 hours, and I'll give you my average speed. But now assume something else. I am driving, and you call me while I'm driving, and you say, what is your average rate of change of distance with respect to time now? Well, unless I look at the odometer at that instant, I can't tell you. So I'm driving, I'm looking at the odometer and say 61 miles per hour. That is the instantaneous, at any particular moment in time, instantaneous velocity. And these two examples are connected to the difference quotient. So I'm going to switch back. So this slope is your question about what was your average speed. And I will say I drove 200 miles in 7 hours, and I'll give you the answer. But when you ask me what is your instantaneous rate of change, you are really asking me the slope of this line, which is the tangent at P. Maybe not at the starting point, maybe 2 hours into my drive. Okay, what will be the instantaneous rate of change? It will be this. The slope of P, of f of x at P, of the tangent at P, okay? The slope here will tell you the instantaneous rate of change x hours into my trip. The slope here will tell you the instantaneous rate of change, which is the speed at that time. The slope here will tell you the same thing. So this is between any 2 points, but the slope of the tangent is what we are after. Okay, so then if the slope of PQ is the average rate of change between P and Q, the slope of the tangent at P is the instantaneous rate of change. Of the function with respect to x. Okay, remember P and Q are close, very close. So now, how do we get from the slope of the secant line to the slope of the tangent line? How do we connect these two? Here's how we connect them, and then we can work on problems. Okay, so if P, this symbol, this arrow, we normally translate it as approaches very important, but it does not equal. So when we say x approaches 1, we automatically know this, that x does not equal 1. So when I'm going to say P approaches Q, I mean P will never, or Q approaches P, P approaches Q, it doesn't matter. P and Q will not be the same point. Okay. So if P approaches Q or Q approaches P, what really happens to H is, if P gets closer into Q or Q gets closer to P, doesn't matter. What happens to H when I move Q closer and closer to P? What will happen to H?
Approaches 0.
Yes. Okay. Which means, what will happen to the slope of the secant line as Q gets closer and closer to P? What it will become? As Q gets closer and closer to P. So this is the initial, and now Q gets closer and closer, closer and closer, closer and closer, closer and closer, but not equal, not overlapping P. What will happen to the slope of this line? It will become the, or closer and closer to what?
Infinity.
We are trying to get to explain how we get the slope of this line. So as Q gets closer and closer to P, the secant line becomes the tangent line. Gets closer and closer. I shouldn't say becomes. So as P gets closer and closer to Q, or Q gets closer and closer to P, H approaches 0. So then the slope of the secant line PQ will get closer and closer to what?
Inches of a tangent line.
The slope of the tangent at P. Do we all see that? One more time. This is the secant line. As Q gets closer and closer here, look what happens. Right? So when Q is away, or I zoom in, but when Q gets closer and closer, the secant line gets closer and closer to the tangent line at P. Of course, we do not write this. This was an explanation, but we don't write this. We have an operator that does this for us. What does an operator mean? Oh, I have a chat. I just saw that. That's okay. Good. So, good. So we don't use this. So we use an operator. An operator? What is an operator? Let me give you a few examples. This is an operator. It's a process that does something to X. And we know what it does. Here's another operator. It's another process that does something to X. Here's another operator. It's a process that does something to X. And so on and so forth. I can continue forever. But the operator I'm talking about that replaces all this explanation is the limit. The limit operator. So we're going to write that the limit of the slope of the secant line as H approaches 0 equals anyone. And I'll sip water. that replaces all this? Very good. Thank you very much.
Sorry.
No worries. This is it. And we are going to learn a lot about this operator. Like this operator and this operator and this operator has properties, has all sorts. So we are going to learn a lot about this operator. Okay. Now I would like to look at a problem that illustrates this process with numbers, because this was all theoretical. We explained what the difference quotient is. So we can start by determining the difference quotient for a few functions. Maybe that would be the best. And as a starting point for next step. And then look at numerical examples for 2.1. So I let you decide. Would you like to start with numerical examples, or would you like to start with determining? This is a big issue for different functions, determining and simplifying the difference quotient. So you tell me what you'd like to continue with. The difference quotient, all numerical examples. If it takes more than 1, 2, 3 to make a decision, I will make a decision. 1, 2, 3. Yes?
Say numerical examples.
Numerical examples. Got it. Good. So let's start with that. I'm going to open my book. So if you'd like to open your book, I'm just doing that and illustrate the average rate of change turning into the instantaneous rate of change. And that's the big deal in calculus. Okay, let's go to the ebook. I'll share my screen. And go to limits, chapter 2, because that's what we are talking about first, limits, and then the rest. In 2.1, click on 2.1. Okay, guys, you're in the way. Okay, let's start with number 3. And let me just copy. So this is number 3 in 2.1, and we have the point 2 comma negative 1, and the function is 1 over 1 minus x. Okay, and I just want to copy these numbers. So 1.5, so I can stop sharing. 1.99 and 1.999 and 2.5 and 2.1 and 2.01 and the last one 2.001. Okay, perfect. Okay, so they are asking us to find the slope of the secant line PQ, 6 decimal places. 6 decimal. Okay, good. So I'm not graphing the function, but the idea is the same. We are talking about P. In this case, is given to us as 2 comma negative 1. And in this case, Q is given to us as x comma f of x. So they're asking us to find the slope of the secant line. And eventually they will ask us to estimate what we are really interested in, not in average rate of change. This is for algebra. We are doing this because we want to determine this. And then eventually we would like to determine the equation of this line. And you can ask, okay, why? For many purposes and many reasons. One of the reasons is later on in a later chapter in which we are going to approximate this function near to using the line. Okay, so that's a big deal. Okay, so I would like to determine the slope of PQ. Can anyone give us the slope of PQ?
Negative.
1 over 1 minus x minus negative 1, which is positive 1 plus
Excellent.
1.
Excellent.
And x minus 2.
Great job. Who was that? I'm sorry. Sometimes all this Joe. Okay, thank you. Good. So you understand that what we need to calculate here is replacing x by 1.5, replacing x by 1.9, and all those. So they're asking us to find the slope PQ for all these values. I'm not going to repeat this process 2, 4, 6, 8 times. No. I'm going to put this function in the graphing calculator and punch those numbers in. So I'm going to create this table, and the slope PQ, I'm going to put these numbers in the correct order. I may need more room, so I'm going to go on the next page. So 1.5 is the smallest, 1.9, 1.99, 1.999. The next number should be 2. It's not here. I will put it in. Can I plug in 2 in this function, in this expression?
No.
No. So I know I'm going to get an error. I'm not going to plug it in. This is for something else. Okay, and then I'm going to continue the table. If you can, I have to write big, and I always write big anyway. So you can continue on the same row. You don't have to move on to the next page or the next row, but I have to because I need room to write those numbers in. Okay, so the next in line is not 2.5, right? The next in line is 2.001, and the next one is 2.01, and the next one is 2.1, and the next one is 2.5. All numbers are in the correct order, ascending order. Okay, of course, this is the x, and of course, this is the slope of PQ. So please grab your calculators. Let me share my screen and go to the calculator. Go to y equals, remove anything and everything you have, or just de-highlight and go to y3 if you want to keep what you have. That's also possible. Okay, so careful. Okay, hold on. So be very careful how you enter this function in the graphing calculator. You need parentheses here, you need parentheses here, and you need parentheses here. If you're missing any of these parentheses, you're not going to get what you want. So the top in parentheses, the denominator in parentheses, and also the fraction, the denominator of this fraction in parentheses. You can say, why don't you just simplify this? I could. Sometimes we cannot. So I want to show it like this, and then we can go back and also simplify it. But sometimes I may have, who knows, a sine of 2x plus 1 over tangent minus 2. I won't be able to simplify that. So that's why in the raw position for a moment, or form. Okay, so let's go to left parenthesis, 1 divided by parentheses again, 1 minus x. Close the parenthesis for the denominator, then positive 1. Close the parenthesis for the top, divide parentheses again, x minus 2. If you fell behind, let me know, okay? So this is the function. Depending on your calculator, you may have used it for something else, but please go to second and table set and make sure, this is not important, but make sure that the independent variable is in the ask mode. Make sure you have it in the ask mode. And now let's go to second and table after you do that. And of course, when 2 is there, I will get error. So now let's enter the numbers we need in the correct order. Where's my keyboard? I need my keyboard. Okay. So we're going to enter 1.5. Then we're going to enter 1.9. and then 1.99, and then 1.999. So let me copy this. We are asked for 6 decimal places, so go back up and move to the right so you can see more than what the calculator is showing us. So the first one is 2. The next one is 1.111111. They want 6 decimal places. The next one is 1.010101. The next one is 1.001001. Okay, moving on now. Of course, I'm not going to plug in 2, but I'm on the other side of my table. 2.001, and then 2.01, and then 2.1, and then 2.5. Okay, so let's go back and see if there is anything in there. So 6 decimal places, 0.99900240001. Okay, and for the next one is 0.990099, and then 0.909091, 6 decimal places, and the last one 0.666667. Okay.
Can you
Good.
show how you put that into the calculator again? I did what you did, but my table's ending up blank.
Because you have to go to table set first. Second and table set. You have to make sure that the independent variable is in the ask mode.
It is in the ask mode.
Oh, okay. So then second and table.
I do second table and it's just blank. There's nothing here.
But you have to enter it. Enter 1.5 and enter.
Oh.
If you don't enter anything, it will be blank. My
confused
calculator
with all the numbers.
but was used before. That's why I didn't have blank. You never used that feature, potentially, and that's why you had it blank. Is that okay?